Look at this, 17 cents, 3.5 cents. Same task, same AI, same conversation. Then I did one thing differently and the cost jumped to 24 cents, higher than even the very first message. The jump was not random. It is a setting most people use tools like Claude Code don't even know exists. It is called prompt caching, and it is the difference between a normal AI bill and one that quietly costs you 4 or 5 times more. This happens without you ever noticing. In this video, I will show you what prompt caching actually is using an analogy that has nothing to do with computers. I will show you the real math behind it with real numbers, not made up percentages. By the end of this video, you will understand why your AI bill moves the way it does and 3 simple habits that stop it from quietly costing you. Let's go. Okay, what prompt caching actually is. Let's say when you talk to AI, you will have 2 major token consumptions happening. One is input and another one is output. Output token consumption is always more than input token consumption, which will be roughly 5x more than input every single time. So input is something that your AI reads each and everything, your tools, your MCP connectors, plugins, everything, the master prompt, all these things will be reread. That goes into this input. Output is something where AI writes. After taking your input, whenever it is giving back something, that is output. So then what is prompt caching? Let's say you're in a supermarket store and the cashier is someone who scans each and every single item whenever you get a new one. So let's say you got 5 items and you got 3 more after some time, and she has to scan each and every single item from the beginning. That's insane, right? Here, there's no prompt caching working. But with caching, it remembers what's already been scanned, and if we get new items, it will just append that. That is what prompt caching is. It basically remembers your previous conversation in the same session. So the thing most people gets confused is whenever you send something, as I told you, without prompt caching, it rereads everything whenever you send a new message in the same session. That leads to more token consumption. That doesn't mean that you need to always repeat your messages in every single message. Let's say you're talking about iPhone and you just want to ask about iPad in the next message. That doesn't mean you, to make sure the prompt caching work, you have to again ask the same question about iPhone to keep that in the context and ask about iPad later. It doesn't work like that. Whatever you ask with prompt caching, it already keeps that in the cached memory, which is basically less present compared to input and output tokens. But building with your own API, something that changes at every message like a timestamp, that breaks immediately. Let me give you an example. There is an intern, he's on his first day and his manager gave his SOP to follow every single day. But let's say that intern has the same set of rules that he needs to follow, but the timestamp, the date on the top is going to change every single day. So the intern is someone who just follows if it is exactly the same like yesterday. But if the date changed, like, he might confuse. He's like trained in the same way, though this doesn't work in real world in that way. But to make it simple, I'm giving you this example. This might not make sense, but it will make sense in this scenario. So if the date changes every single day, he'll think like something has changed and he will reread the document again and again. That is very inefficient way to work or to learn something, right? So that's exactly what happens in the AI chat. So whatever you talk in the same session, it automatically keeps that in the memory, like tools, plugins, MCP, or whatever you connect in the same session in your Claude Code, it keeps in the memory and it communicates. As soon as you clear that, again, it rereads the entire thing. So let's take an example of Opus model here. It costs about $5 per million input tokens and $25 per million output tokens. And output tokens are always the same, with cash, without cash, doesn't matter. It'll be always the same, $25. The changes you will notice will be in the input tokens only, which we are going to talk about in this video. So here, for instance, remembering the cash takes about $6.25 per million tokens. So you might think this is expensive than the base cost, right? But let's say you are doing a 10,000 token setup and you in the same session you are messaging, you sent about 20 messages back and forth. If model rereads your all 20 messages again and again, it costs about $1.10 total. But if it caches your data once and reuses it 19 times, then it costs about just 26 cents, which is way less. So generally to cache the data, it takes about 1.25 times more than the actual base input price. Cache read is about $50 per million tokens, which is 10 times cheaper. So you might ask, like, we are already paying $1.25 upfront and we got 26 cents. So if we do the 20 messages, it's just 1.10. That is way less than what we paid already. But let's say you're building a complex app or you're doing a long session, then this matters and this shows a lot of difference. That's exactly where the prompt caching makes sense. So here are the real tests I ran in the terminal. So I sent a input, something like this, and the cost here is 0.17. And next to the second message I sent here is something like this, and it says done, and the cost is 0.035 something, which is less than the first one. But the third message, as you can see, it went up to $0.236. Why? Because here I used Opus 4.8. I changed the model in the mid session. That costed me more because if you change models in mid session, it automatically rereads each and everything to understand what's going on and what's been discussed before. So the last message in the same session costed me more than even the first message. So you need to make sure that you don't do this in mid-session. Switching models costs you more because the model needs to reread everything. And also clearing out too often in the same session costs you more tokens. If you're doing the same task, you have to make sure you will wait at least for 65% or 70% of the context to fill, and then you can compact or clear. You have to clear the task only if you are switching to a completely different task. But if you are discussing the same thing, you have to make sure that you are past 60% of the context window or 65%, or you can even go up to 70% in some cases. Then you need to compact but not clear. Compacting also resets the context window and it keeps only the important summary what we have discussed, but also even if you ask something similar to what we have discussed before, it might forget because we already compacted the chat. It keeps only the important things. So this doesn't mean that everything is cached and you will save tokens. Okay. So 4 things to remember. Output is never cached. Only the repeated input gets the discount. Next, the match. It should match exactly word for word from the very first character, but this is only for some edge cases. As I told you, when you're building your own API or something like that. But in your regular chats and in your regular conversations, it works the same way I told you before. Next, switching models midway in the session resets the cache completely every time. So you need to be aware of that. Next, the cache read number. Claude Code doesn't explicitly show this number to anyone, even in the /usage or /context commands. I'll give you the resource guide in the description below. So if you want to check that, you can go ahead and use that. So that is all about prompt caching. Hope you got the idea. This is a simple topic, but I just want to cover this in a quick video. Hope you like this video. And if you want more AI videos and AI breakdowns like this, subscribe to our channel. I'll see you in the next one. Bye.